I would like to welcome all, and thanks for attending our book club. Welcome, Dr. Ale. How are you?
I'm good. How are you doing?
We're very good. We're so happy to see
I'm
you. Thank you for joining us.
sure.
We're doing a lot of agriculture in Turkey.
Uh-huh.
Yeah.
Okay.
After reading your book, I started asking many questions. Thank you for writing that beautiful book. I was just saying, like, since we're, cultivating all these fruits and vegetables, is it feasible spending all these waters? Because I've read that we're spending 72% of the groundwaters in agriculture. So
Yeah, that sounds right. Yeah.
I was so amazed to read the pistachio. They were raising pistachio in California that you were mentioning that spending excess amount of water. So I was just thinking, how are we doing in like Gaziantep?
Yeah, that is I think California is a major producer of pistachios. So and they have a lot of pistachios, that's for sure. Um, Now they have in California now they've focused a lot on what they call flood managed aquifer recharge. Um, and it turns out pistachio trees which have to be, you can't just, you don't have a fallow season, right? So it's all year round, but you can flood them and it works okay. It doesn't hurt the trees.
Yeah, it's amazing to learn all these ways to provide sustainable agriculture.
Mhm.
Dr. LA, the floor is yours, and you may.
Okay, I put together some slides per your request
Oh, thank you.
that
Thank
we
you.
can kind of get us going, and then we can do Q&A type approach, however you want to work it.
Yeah,
So
sounds great.
you wanted a, a presentation on Turkish groundwater also as part of this?
Yeah.
Okay, so I mean, and aha, there we go. Okay, so I wasn't exactly what sort slides to put together, so I just gathered some that were sort of a general interest. So just a lot the importance of groundwater from a global point of view, which we've kind of been talking about. From drinking water and from agriculture, as well as environmental systems. A lot of environmental systems depend on the groundwater that recharges streams. Um, and then this is a figure that was done a while back by actually the British Geological Survey folks. And it shows around the world some of the major aquifers. And I'm looking at Turkey here, and it looks to me like they have you classified as a overall region with complex aquifers, but they distinguish between groundwater basins and the regions with complex aquifers, and then regions with little or no groundwater are in the lighter color, although groundwater can be very important in many of those areas, such as in much of Africa that's shown there. So actually, it's interesting. 5 countries account for 60% of the world's groundwater use, with India leading the pack and having basically twice as much as the next two, the US and China. But Pakistan is another, and Iran is another one, which is actually having a lot of problems with their groundwater resources and water resources right now as we talk. And then if you look at the global depletion, you can see the India issue there quite easily. So over here, that's the Central Valley where your pistachios are being grown. And you can see the Western US. Not as much in South America. A lot of the depletion here is in South Africa or along the coast here. Saudi Arabia, which I'll talk about in a moment, Iran, and China, of course, have major areas of groundwater depletion. So there's the concept of groundwater sustainability, which is not really it's not like an equation that you can solve. It's more of a general approach, which recognizes that there are a number of environmental, socioeconomic consequences of groundwater pumping, and the challenge is to develop the resources to meet the current and future beneficial uses without causing, and I think the key word there is unacceptable. And so it's a societal question actually. And that's what I guess I say that next, essentially the end result of public acceptance of the trade-offs of development. Can't develop groundwater without having some impacts. And as groundwater hydrologists, we provide the information on the long-term consequences of pumping that can help in making these societal decisions. At least that's the ideal. We also, part of this, need to consider management practices. A key one, actually, I've been involved with a lot recently is managed aquifer recharge. And actually, what I've included there a link to the International Association of Hydrogeologists on their link to their managed aquifer recharge sites and publications and so forth. And I guess I would add, if you're not familiar with them, that's a very good, they have a lot of information available that they make generally available on their websites. And they actually hold an annual meeting somewhere around the world every year. And next year's meeting in September, I think it is, 2026, is in not that far from me. It's in Budapest, Hungary. But the other issue is increasing use of recycled or reclaimed water. Sounds like that's a topic you might be familiar with, Aikla. And then the conjunctive use of groundwater and surface water, so using them together. The spreading basins you see is actually recycled water for the most part. And it's the first wastewater treatment plant designed specifically for managed aquifer recharge with recycled water. It's been going on since 1962 in the Los Angeles basin. So the sources of water to pumping wells in say a stream situation is if you look at time, if you just had a steady state pumping and you look at a time and you look at the percentage where that groundwater is coming from. And some of it's coming from groundwater storage, some of it's coming from stream flow capture in this particular case. And what you see here is an idealized situation in which gradually your percentage of groundwater is coming from storage is relatively small compared to that comes from stream flow capture. So there's a major connection between groundwater and stream flow in many, many situations across the globe. Just as an example here from the state of Arizona, let's see, there's an area of pumping here. And then the question is, this is a little Colorado River here, it's going to the Colorado River. But the question is, in these two little creeks here, what would be the effect of hypothetical effects of pumping there on those two creeks? And so what you see here on the right-hand graph is that they pumped between 2010 and 2060 in this particular scenario, and then they turned off, then they wouldn't pump further. And what would be the impacts on this stream? And so what you see is that after they turn off the pumps, two observations here. First of all, there's impacts on both streams, not just the nearest stream. Okay, so this here is lower Clear Creek, and this one is the Chevron Creek. And so it's not just the most closest river or creek that's affected, it's multiple creeks. And the second of all is that after this 50 years of pumping, if you look ahead another 50 years, they're still increasing their streamflow capture. And I just anyway, so it's sort of illustrating the long-term effects and the gradual nature of these kinds of effects. So next, let's think about all aquifers are not created equal. So here's Saudi Arabia, which was the world's sixth largest wheat exporter by about 1992, and it's a non-renewable groundwater resource for all practical purposes, since there's not much rain there, and the groundwater is essentially a legacy of past climates. And by 2000, Saudi Arabia had achieved, if you will, 2/3 of the world's depletion of non-renewable groundwater. They decided at this point that they would essentially get their wheat from outside the country. It wasn't worth growing within Saudi Arabia. But so you have these very large non-renewable groundwater resource issues that can be exploited, but they are very finite. Okay. Then India, we mentioned. So this happens to be northwest India in the Punjab area. And this is a GRACE satellite, measures gravity from space, changes in gravity. And what you see there is a very large area of massive groundwater depletion. Now, it turns out that because of the area also underwent a lot of surface water irrigation back when it was part of the British colonies, that they actually recharged a lot of water over time, so that it's not as dire a situation as it might otherwise be, although they're continuing to deplete the resource. However, if you go down here and south in India, you're basically in hard rock, lots of farmers and so forth, et cetera. And groundwater depletion is a major issue, as we talked about in the book, as we talked. The other issue, of course, in India is arsenic in West Bengal and in Bangladesh. I mean, this just shows a well that has, I think that's been painted green because it's a safe well to use. They had a massive survey of arsenic at one point, and they essentially painted the wells that were contaminated above the UNESCO standard at that time red, and those that were safe green. Of course, if that was your water supply, it was a little hard to, and you didn't really feel like there was any effects. Many people continued using those red or contaminated wells. Anyway, it's a major issue that they've had to deal with the eastern part of India. And then, of course, water is also important, as I mentioned, for particularly in poorer communities like in sub-Saharan Africa. These kids here are from Madagascar. So just a mere fact of having sanitation here is very important for them. So it's a major issue in some of the poor regions of the world. There's also another kind of aquifer, and I'm not sure if you have much karst in Turkey or not, but this is in Texas, the Edwards Aquifer, which is essentially a karst aquifer that acts like a surface water reservoir, and the stream here, Comal Springs, can go dry if they pump too much water or get into too serious a drought, which has an impact on endangered species. And they actually have, shown on the right there, they actually have on television, believe it or not, will have on the weather the status of their aquifer and the situation, particularly as they get into climate type situations, droughts. And then finally, I think, is land subsidence, which is a big issue in the U.S., in the Western U.S. This shows a scene from they're not too far apart, actually, where that photo was taken back in the early 1900s and the photo taken in the late 1900s in the Mojave Desert. And you can see the effects of groundwater pumping on land subsidence there. And these can be irreversible if you're pumping heads fall below previous heads and you have a geology that's full of fine-grained materials like shales and things like that that are compressible. And then of recent interest, there's long been a lot of interest, of course, in transboundary rivers in the world. But actually, since about the early 2000s, there's been a fairly strong effort to identify and work towards cooperation on transboundary aquifers across the world. And you can see, I don't see them here in Turkey. You may have definitely not up to your northwest as an area. A lot along the border of the U.S. I've actually worked with Mexicans on. Canada, we have a large basin up here that we share. And then as you can see, there are many others scattered around the world. So a little bit about governance in this particular situation, which is a challenge. And unlike surface water, where you may have a sort of a limited number of sort of major irrigation districts and things like that, groundwater tend to have a lot of people that are taking from the same resource. And that can create challenges. And I think the example we used was contrasting the cooperation of the water jury of Valencia, Spain. This is a group that's been going on since a long time, I think over 1,000 years actually, where they meet on the Thursday afternoons. And if you're a farmer on the surface water irrigation systems around there, then you can bring to this particular group sitting inside the enclosure there outside the front door of the cathedral, your issues, and they will deal with it. They don't keep any records. They just tell you what the result is. And this has been going on a long time, and I guess it must be somewhat successful for that. In contrast, in Spain, if you go to the region of La Mancha in central Spain, they've had a lot of difficulty in bringing the groundwater pumpers to reduce their pumping, to reduce effects on wetlands, as shown here, and other issues. And really, the moral of that particular story is that it's really difficult to change things or to reduce pumping once you have large entrenched group involved. And we talked a lot about that's a major issue that exists in India as well, and many and other countries. Is once you get a lot of farmers, they can group together and they can make it really difficult to reduce the pumping that they have. So, and they've worked through a lot of these issues in various places, but it's challenging when people's livelihoods depends on the groundwater they're pumping. So, from a scientific point of view, their monitoring is very important because you can't manage what you don't measure, as the saying goes. And so, what this diagram shows is that's kind of evolves over time in terms of the link between monitoring networks and modeling and use of data of hydrologic studies, including environmental tracer data. So you have, ideally, in time, you have a long-term monitoring networks that are operational, provide a good long-term database for you. And then on a periodic basis, one revises their conceptual view of the situation, known as the conceptual model, translates that along with whatever geologic and hydrologic studies have undergone in the meantime, into a revised simulation model that then predicts forward and then hopefully manages from that. So that's the ideal. I'm not sure how often it happens, but that's kind of the ideal monitoring and modeling type approach. The other thing that I should add is that hydrogeologists over time have a lot of tools in their toolbox. This is just one of the more popular ones these days, and it was actually started out in Denmark. Denmark has a very strong aquifer protection program in place. They also have a lot of pollution, nitrate, and so forth from their agriculture. And so they have, as you can see from that map, a lot of their groundwater is very vulnerable. And they actually, the Danish Geological Survey and a private firm developed what's seen on the right, which is they fly around with this hoop here that's generating electromagnetic signals, and they can use those signals to see the response that they get in essentially dependent upon the resistivity or conductivity of the subsurface. And they can get a generalized map of subsurface sands and gravels versus shales, or perhaps water quality is another thing that affects the electrical conductivity of the ground. But anything that affects the conductivity of the ground, that they can map in 3 dimensions at a coarse scale, but nonetheless you can combine that information with more detailed well information to get a much better handle on your subsurface materials. So I think that's the end of my talk, just to kick things off here. I hope that's what you were looking for.
Thank you very much. Actually, we were so amazed to read your book, and now seeing the graphics. Thank you for these beautiful pictures and graphics. And Dr. Copty, would you like to give us some information regarding to groundwater management in Turkey?
Yeah. Hello again, everybody. So I'm Nedim Copty. I'm a professor here in Istanbul at Boğaziçi University at the Institute of Environmental Sciences. And my main area is actually groundwater. I teach and do some research on groundwater, specifically on groundwater modeling. And actually, you will see some similarities to what William has presented in some of the slides. The first slide, for example, we probably looked at the same reference. You had the first 5 countries that rely on groundwater. Mm-hmm. Turkey is the 10th in the list. It uses approximately 35% of its water use comes from groundwater, and the other 65 comes from surface water. Some regions, though, rely very, very significantly on groundwater, and one basin is the Konya Basin that I had the chance to work on in the last few years. They use groundwater up to maybe 80% and perhaps more. It's a big basin in the middle of the country. This is the Konya Basin. It's a big basin in the middle of the country, and water is primarily used there for agriculture. Some of the challenges that this basin, maybe I can comment a little bit on this basin, some of the challenges that it faced. Number one is the climate change. In the last couple of decades, rainfall has decreased by maybe about 10%. Already it was quite low. And many of the surface water bodies are drying up because of the climate change and of course because of the extensive use of groundwater in the area. So the groundwater stops feeding many of these surface water bodies that exist. So the first challenge we have seen is that climate change is making difficult problem even more difficult. Another aspect is that farmers are aware of the water problem there. So they have in general switched to more efficient irrigation systems, especially in the last 10, 15 years. But the water savings that are coming from this more efficient irrigation systems, they are using that extra water to actually expand the irrigated land and also to grow crops that need more water, maybe more profitable, but at the same time more water. So the water demand continues to increase, although they are using more efficient irrigation systems. Another major problem is that, the regulations in Turkey are quite clear, and there are institutions that oversee the use of groundwater. But a challenge that we have seen, and also the stakeholders there always tell us, is the very, very large number of unregulated extraction wells, around 100,000 in this basin. And so it makes it very difficult to enforce any laws or any regulations or any quotas on extraction if you have such a very large number of unregulated wells. And maybe the fourth challenge that we have seen is regard to water quality. There are a number of issues related to water quality. Some, for example, is on the excessive use of fertilizers and pesticides. Some industrial activity, though there is not much in Konya, but in general, there is some industrial activity and the discharge of wastewater. Soil salinization is a problem and getting worse because the excessive use of irrigation, continuous irrigation, is making the surface of the soil to be quite saline. And this is an image of what you would see. The soil is becoming soil, with a high level of salt that affects the crop yields and the crops that they can grow. So these are the four, of course, there are others, but probably these are the four major challenges that this area is seeing, and actually probably many other areas in Turkey and worldwide. And the result has been that water levels continue to drop. And one problem that the Konya area has is that the development of sinkholes. So you see many sinkholes like these two images over here. Some are old, but some are appearing every day because of the excessive use of groundwater and the drop in groundwater levels. And that is actually scaring a lot of the local people there, the farmers and so forth. They worry that one day their field, they are worried to go to their fields because the water level is continuously growing. I just wanted to add, a couple of perspectives from the studies that I have been involved, and specifically in Konya, but I think they exemplify many of the other problems that we are facing worldwide. Thanks a lot. I'll be, of course, glad to respond to any questions also and participate in the discussion.
Thank you, Dr. Copty. Yes, so actually, Dr. Ale gave like a brief explanation of his beautiful book. And we wanted to see what's going on in Turkey, and I was really curious. And preparing this very well informing presentation. Thank you very much. Yeah. So anyone wants to ask questions, please feel free to ask. I wanted to ask, we're growing a lot of vegetables and fruits. And Dr. Yavuz, how is your perspective as an agricultural economist on the issue? How is Turkey doing in terms of growing the fruits and vegetables and spending all these waters, and are we doing sustainable work?
Thank you very much, İclal Hanım. Since we are talking about underground water, it is better to compare the global average use of groundwater and what is the percentage. It is about 40% equipped for irrigation uses groundwater. But in Turkey, it is around 20%. So it is maybe in terms of percentage, it is half of it. So use of groundwater is less in Turkey. Surface water, because we have lots of rivers and dams, surface water usage is high in Turkey. Since I'm not working on water or irrigation systems, I'm an agricultural economist, and I look at the policy aspect of the issues. So in terms of irrigation, Turkey has several policies to make use of efficient use of irrigation water. We can group these policies under four titles. One is grant support for pressurized irrigation systems. I mean, going away from using surface water to pressurized water. So we have a grant support and regulatory target to use irrigation water efficiently, and also large-scale infrastructure investments and modernization projects. I think recently $757 million approved by World Bank to make use of this large-scale infrastructure so that Turkey can use irrigation water more efficiently. When I say more efficiently, it means that going away from traditional irrigation system to modern irrigation system, which are sparkling irrigation, dripping irrigation, etc., because these irrigation systems use less water than the traditional irrigation system. And technical support also to teach farmers to make use of irrigation water more efficiently, because farmers think that the more water we use, the more productivity we'll have, but that's not the case. In order to make use of efficient irrigation water use, I think the farmer has to be taught about this. And İclal Hanım, because you invited me to talk about this, I talked to a friend who is working in the area Konya. He is agricultural engineer, and he told me that he started working in Konya in 1998, and at that time the groundwater level was 25 meters to 40 meters. I mean, you can take water from 25 or 40 meters in this interval. But in 2025, it goes down 100 to 250 meters. So this means that ground is down. And also the water quality is going down. So this is the case in middle of Turkey. The city of Konya, the province of Konya, and other cities around the Konya. And also there is illegal use of groundwater. In order to use groundwater for irrigation, you have to register. But he told me that 80% of groundwater use is illegal. What do farmers do? They rent an area of land and they use groundwater irrigation system in that land, and they also use for their land. So the amount of water they take from ground is increasing very fast. And another information, he told me that 25, 30 years ago, corn production in that area was 50,000 decars. You know, decars, acre is used. Around 4 point some decars is 1 acre.
It sounds like it's the same
Acre,
as
yeah. So 25, 30 years ago, 50,000 decars of corn production did exist that in that area. Now it is more than 1 million decars. So it increased by 20 times in last 25, 30 years. This is happening in Ankara and in Konya, in Karaman, in the middle of Turkey. So as you know, when you are producing corn, you need to have more water. Compared to wheat, he told me that he's working on wheat. So he told me that corn uses 10 times more water than what wheat production is needed. And also climate change also affects this. He also told me that even though from traditional irrigation system to modern irrigation system, but the area of irrigation area increasing, and in modern irrigation system, they use more water than it is needed. For example, even in dripping irrigation system, they use water 36 hours when they irrigate the land. Actually, maybe half of these hours is enough for the productivity level. As I said before, farmer has an understanding that the more water you use, the more productivity you will get. That is not the case in most cases. Another thing happening in that area, electricity cost of withdrawing water from ground is increasing. This is little bit decreasing the level of water use because the cost of taking water from ground is going up. And also, in addition to corn, in that area, agricultural production going away from wheat production, which need less water, to sugar beet, to forage crop, and corn for feed. So this also increases the use of groundwater. So all of these trends are making to use more groundwater over there. Well, I think, İzlal Hanım, these are the things I thought that I should mention, which are left from previous speakers. Thank you very much.
Thank you very much for sharing all this information and joining us. Thank you. Dr. Muratoğlu, he's the water footprint expert, hydraulic engineer, and he's the one who's bringing this to Turkey. So we wanted to know what you wanted to tell us about on your expertise area and also its relation with the groundwater, please.
Okay. Thank you. Today, I'm gonna talk about something that affects every single of us, every single day, but most of us never really think about it. It is called water footprint. So thousands of years ago, our ancestors left their footprints in the sand and mud. These footprints tell us where they walked, where they lived, and what impact they had on the earth. Today, we have a very different footprint on earth as humans. But instead, our early ancestors, we are leaving a much bigger mark on this planet. We don't just leave footprints on sand anymore. we are changing the entire planet. That is what scientists called as water footprint. So there is a big reason for this. We are now 8 billion people on this planet. So this means we need more food, we need more clothes, and we need more products, of course. So also we need more water to produce all these products. So you see the groundwater, the 30% of 2.5% is composed of groundwater. You have probably heard about the carbon footprint, the amount of greenhouse gases we produce. But today, I want to introduce you something equally important, the water footprint. Just like carbon footprint, the water footprint measures the impact of our actions. But instead of measuring carbon gas, we are measuring water. So let me show you an example. To produce just 1 kilogram of beef, we need about 15,000 liters of water. With this water, that water is enough for one person to drink for almost 20 years. So why is so much? Because cow needs to drink water through its life, but more importantly, we need to grow all the food that cow eats, and grass and grain and everything. Now let's talk about food. Let's say it costs about $5. But what is the real cost? The ecological cost, the cost on water resources, the cost on carbon, the cost on energy production maybe. The real value includes all the water needs to produce it. So everything we eat has a hidden water cost. So as water footprint experts, we are studying, we are quantifying this hidden waters. Different products have different virtual water contents. We called as virtual water content. Imagine if a restaurant gave you a water receipt along with your bill. Instead of just showing the price, it will show how much water was used to make your meal. A chicken dinner that will show around 4,000 liters of water. A salad may show around 300 liters of water. So this can help us to understand the real impact of water that we eat, the water that we eat, not drink, that we eat. So water footprint has three components. We separate it to the three different colors to understand and to manage it. Blue water, green water, and gray water. Blue water is the total amount of surface and groundwater resources that is used to produce a final product. Green water is the total amount of soil moisture or rainwater that is used in a final product. And gray water is the amount of fresh water that is needed to assimilate the load of pollutants to meet the environmental standards. Okay, let's move on something very interesting. Water doesn't just flow the rivers. It's a realistic case, but if we look at the virtual water, there is another world here. It flows in virtual rivers through global trade, through international trade, imports and exports. When a country like Saudi Arabia, let's say Saudi Arabia, imports wheat from Turkey, they are actually importing water also. So the water needed to grow wheat in Turkey indirectly transported to Saudi Arabia when you export your wheat to the Saudi Arabia. So if we look at the overall picture, we see that there are some virtual rivers. Flowing between countries through global trade. So these virtual rivers sometimes exceeds realistic rivers. And finally, these are references you can use for further reading. So what should we do? You know a little bit about water footprint. You can make better choices. What can we do? Please support farmers who use smart irrigation methods like drip irrigation and some other modern techniques. Okay, that's all from me.
Thank you
If
very
you
much.
have
Thank
any
you for the
questions.
information you shared, Dr. Muratoğlu. Thank you very much. Dicle, she's a genius water expert. She's been contributing to our beautiful city, Istanbul. And so we were talking like how we're missing the part of groundwater in our water dream. So, Dicle, I want to ask you, how do you see the groundwater in a picture of and Istanbuli. Would you like to share?
Yes, thank you, İclal. Hello, the other speakers and participants. Yes, I'm environmental engineer. I have worked water treatment operation engineer for 20 years, and now I am a research and development department of İSKİ, Istanbul Water and Sewage Administration. Yes, when we consider the groundwater, the water demand of Istanbul is very high, 3 million cubic meters per day. But only 5% of this demand is supplied from groundwater. These are rural areas, and there are villages here, small villages, almost 100 villages. And every village has its own drilling well, and other 95% of the water is supplied from surface water. There are big central water treatment plants in Istanbul, and water is treated and distributed. Yes, so Istanbul Water Administration operates these wells, but only for aim of drinking water, not agriculture. The agricultural usage of groundwater in Istanbul, all over Turkey, is responsible of government water works. Yes, and there are also 3 big aquifers in Istanbul rural areas, and the water flow rate is higher these aquifers, and this water is treated. It is need treatment because it has high iron and manganese concentration. Treated, disinfected, and it's pumped to the surrounding areas. But mostly every village has its own drilling wells. And when we look at the quality, nitrate values is low, almost 1 milligram per liter. The limit value is 30 milligram per liter, so this is low value. 20 years ago, nitrate values were higher. 30 ppm, 40 ppm were possible. And 30 decades ago, agricultural activities and animal farmers were widespread in Istanbul rural areas. And these activities has decreased sharply. And also, septic tank usage has ended. Every house had its own individual septic tanks. 10 years ago, wastewater treatment plants has installed, and wastewater treatment plants has built for every village. In rural areas of Istanbul, there are 80 wastewater treatment plants. These are biological wastewater treatment plants. And so that caused the decrease in nitrate concentration. That is very good because nitrate problem harmful for human health. Nitrate is important by the treatment. Iron and manganese treatment, also arsenic treatment, is not difficult. Oxidation and sand filtration is possible to treat these pollutants, but we consider nitrate. Nitrate is very soluble, so conventional method is not enough to remove nitrate. So we have to apply membrane systems. Ultrafiltration may not be enough. Nanofiltration can be necessary for nitrate removal. Luckily, we don't have arsenic problems. We measure arsenic, but low concentration. So these are about the water quality parameters. And at the end, I want to make a comment. This book was very useful for me. The most interesting thing for me to recognize groundwater and surface water as a single source. Because for long years, I believed that these are different sources. Because groundwater and surface water quality characteristics are very different. For example, surface water polluted with natural organic compounds, and that caused taste and other problems. And to remove these compounds from water is difficult. I know this very well in water treatment process operation experience, but groundwater has been protected from organic compounds. For example, when we look at the surface water in Istanbul, Terkos, important surface water of Istanbul, TOC, total organic carbon content, 5 milligram per liter, 6 milligram per liter, but in the same water basin, groundwater content is less than 1 milligram per liter. So this low organic matter content is a very valuable source for drinking water. So low organic content conditions, you can stop chlorination, disinfection. This is possible. So this is a very valuable, very high quality water. So when they look at the water quality characteristics differences, don't prevent us think about these are separate sources. So I understand we recognize them as a single source, but I like thinking about fate of pollutants in the environment, and I see that the most important factor affects pollutant existence in the water is solubility. For example, nitrate is very soluble. We see nitrate in groundwater. For example, aluminium. Aluminium is the most abundant metal in the soil, but we don't see aluminium. We don't find aluminium in groundwater because it is absorbed highly to soil. So when we consider organic matter, that seems to me very interesting. Organic matter absorption is low absorption tendency. Organic matter don't absorb sand, for example. I know this by experience in water treatment plants years. You apply very low filtration rate, but again, organic matter cannot be removed. Only activated carbon, it is a very high absorption capacity can remove organic matter. So it seems so interesting that how organic matter can be removed in soil. I would like to know about this. I think there are some different directions, soil and organic matter. So organic matter decreased to such a low levels in groundwater. Thank you. Have a good night.
Thank you so much, dear Dicle Tatar, sharing this wonderful information of our beautiful city. Please free to ask questions.
So what is the primary, do you have karst terrain in Turkey, limestone?
Yes, there are some parts of Turkey which are karst aquifers, as well as sediment.
Mm-hmm.
Yes, it's good. That's why in the map you showed, it says Turkey is quite complex because there is not a single big aquifer that covers, a big part of the country, but there are different aquifers. I had actually a question. First, I would like to thank Dicle Hanım for her nice commentary, and also, of course, Abdullah Hocam for the perspective of, we don't think about the water footprint much.
Mm-hmm.
And Fahri Hocam also, because many of the things he said, actually, it confirms some of the challenges we have. But the question is for Dr. Ali. When we are significantly overusing the groundwater resource, how can one start by approaching sustainability? It seems like technology by itself, the more enhanced irrigation systems is not enough. So it's not clear how one can approach this point of sustainability. You have any comments on that?
Yeah, so there's no special magic approach for sure. Speaking mostly from my experience here in the United States, often it's happened in certain ways. Either the government has taken strong measures, and I'll give you an example in California. So California also has been way overusing their groundwater, particularly in the Central Valley, where all the crops are grown, but elsewhere in the state. And somewhere along the way, they passed a regulation in 2014 in the midst of a drought. So I guess that's one lesson. Best time to try to pass legislation or get people's interest is during a drought. You don't want to waste a drought, as the saying goes. But the way they attacked the problem was they created what they call groundwater sustainability agencies, and actually they were self-created, and there's like 200 some of them. There's a lot, and they each had to come up with a groundwater sustainability plan, okay, which took a lot of effort, and it's an ongoing activity. But they then had to pass those sustainability plans past the state of California. So there was a Department of Water Resources in California that evaluated all these plans. And the pressure actually created a fair number of them have created pretty good plans, I think. But there are others that didn't pass. There were a half dozen, maybe 5, 10 others that did not pass their plans didn't pass. And let me say a little bit about the requirement. So they recognized that you can't solve this kind of problem overnight. So they set a date that they had to achieve sustainability by 2040, and they had to develop a plan that would get them there. So I think that's another lesson, is that you can't solve the problem overnight. But if you can get people on track, it's easier to sell somebody something that's going to happen in 2040 than it's going to happen in 2026, right? And then they had there's 6 to 10 that failed almost all the plans failed for their first run through, but that was resolved fairly quickly. But there have been 6 or 7 that have not. And they gave a number of those plans multiple attempts to come along, because what happens if they don't meet it, then farmers have to pay a certain fee and the state essentially takes over management of that particular sub-basin. So they've still got the half dozen that they're going through. But so that they've set up a long-term program, got rewards and punishment in it, okay? And tried to get everybody on track. And I think it's all things considered, it's a very successful program. Unfortunately, they had the same ideas 40 years before that under the same person, under the same governor of California, Jerry Brown. But it took a really bad drought to get them to march along. So, and ironically, the state of Arizona, which is in the Southwest, suffers its own set of plans, actually initiated a program back in 1980, a long-term program that has benefited them also considerably in the parts of Arizona that have surface water, that have access to what's known as the Colorado River Canal, which is bringing water from the Colorado River into central Arizona. And they've made good progress in those areas. Outside of that area, where there's not this ample source of surface water to try to help bring the situation into balance, they've had another much more difficult and really haven't made much progress. But so they're like 40 years ahead of California, but they're still working on trying to get to where they want to be. So it's there's no magic bullet. It's a long-term process. Somehow you got to get a lot of, as has been mentioned by a number of the presentations here, to get a number, including yours, I think, a number of people on board. And it's very difficult to sort of corral all that effort.
So for the Valencia example you mentioned, I think it was a grassroots effort to kind of address water challenges. Is that correct? But then on the other hand, sometimes you need a more up-down approach when solutions cannot be found very easily.
Right. So it's balancing both in this case. The law was passed by the state so there was a lot of pressure to deal with it. In fact, the hydrogeologists were very active in California. So the Groundwater Resources Association of California basically went on an educational spree with the state legislature to try to explain to them why they needed to take action. And also it was a situation in which water levels were dropping rapidly because the drought was a very, very serious drought. And so kind of caught enough people's attention that they allowed to have the state come in and have a major role and also serve as a policeman, if you will. But the individuals had the opportunity to try to solve this problem themselves, and they recognized that it would take a while to do that.
Okay, thank you.
Thank you, Dr. Ali. Actually, there are many points in your book, but one of the things that I saw, since you're mentioning about Colorado, the excess use of the groundwater, and then later on they prohibited it, and the poor farmers. My heart was broken about the farmers, and the farmers shouldn't be also left like that as well. So as of today, like in the United States, you're sustaining the management. So today, in what percentage, like you're controlling the agriculture and the farmers in terms of that you're sure the farmers are doing good and also the water is spent sustainably? So like how you dealing it with as of today?
So important point here, the overarching point is that the water resources, groundwater resources in the United States are regulated by the states. So the federal government has very little role in regulating groundwater other than groundwater quality. So they set standards for drinking water quality and so forth. But so it's a state function. So as a result, the ability to deal with the issues that you raised there varies tremendously from state to state, and also within states. So you have states like California like Arizona they were actually forced to do it because there was a role for the federal government in Arizona, and that role was that they wouldn't fund the Central Arizona project unless Arizona did something to manage its groundwater. So there was a little bit of a string there from the federal government, and the funding arrangements from the federal government can influence things in terms of you have to do this if you want to get this funding. So I guess that is a national role. But then you look at other states, Colorado, you mentioned Colorado. So Colorado has a very unique regulatory approach to to groundwater in their alluvial basins like the South Platte. And so today they're doing fairly well in that regard. One of the bigger problems is that the Colorado River feeds a lot of water to Colorado's eastern Colorado, and they relied heavily on increasingly getting that water, and there really isn't any more water to be gotten. So they've had to move there. I'd say the other thing though is that since I noticed a lot of you have a lot of experience and knowledge in water treatment, wastewater recycling has become a very big issue in the United States. It's not a perfect source because lots of times that water is actually used downstream after being processed through a wastewater treatment plant. But there's a number of states, particularly California, Florida, Texas now. Texas has been slow to adopt things. There's a good example there. So Texas tends to not regulate their groundwater as strongly as other states do, but they're actually, because it's growing, the state is growing so fast and it's really stressing your groundwater resources, they're actually starting to get the idea to have a more rigorous approach to their groundwater management. But they're also big on water recycling as well. So that's a major issue that helps things along. If you can bring in some more water, that helps while you're simultaneously trying to work on the demand management, and sometimes that combination works.
Oh, thank you. For my understanding is since you're requiring, for instance, more and so on technologies to control the levels of groundwater, so you probably are pretty set up as US, like, right, in terms of groundwater.
Well, it depends. It depends. We still have plenty to go. We have a lot of issues to. California has not solved all their problems, and there are a lot of controversies. In California, predominantly in the Central Valley, the biggest controversy is there's a thing in the middle called the Delta, which is where water normally leaves California and heads out San Francisco Bay. And that Delta needs so much water from an environmental point of view that there's a lot of contention about how to manage that system, so forth. So there's plenty of challenges out there.
Thank you very much. And also, Dr. Copty, how are we doing in terms of measuring our groundwater levels in Turkey? Like, in what percentage are we succeeding doing that and also managing that? And another question, was groundwater fossil? Is that why it became like this in Konya? Can we recharge it? Is it possible?
Yes. So for the first question, the State Hydraulic Works is responsible for monitoring, for giving permits on groundwater extraction. And in recent years, they have been installing a lot of these automatic sensors that monitor water levels, Konya included, plus other regions, water levels, salinity, temperature. So data collection has improved significantly in the last, I would say, 5-10 years. And there's this switch to automated systems. The data, though, is not public, and I don't know how it is in the US. So as researchers, we would need to write a request to access the data. We cannot access it directly ourselves from some web page or something like that. But at least, I mean, the monitoring is improving in Turkey. But accessibility to the data is another issue. On your other question, what was it?
What's the percentage approximately we're controlling right now?
Oh, I mean, like in the area of Konya, there is more than 150 automated monitoring stations, which gives us a good idea of the water levels, and they are dropping, obviously. And the water that is being used is not being replenished.
So is it possible?
Yes, I mean, we can say that because it's not the recharge that is coming from precipitation. Maybe on average in Konya, I don't know, like a meter per year drop. In some areas, much more. In some areas, less. It's a big area, and agriculture really is the dominant activity. So it's very difficult to limit to the farmer the amount of extraction. They have to be compensated somehow for the loss in income.
Thank you very much. So can we say in Turkey, what's the fossil groundwater percentage among our groundwaters? Do we have such a data?
I don't really know, on a national scale like that. In some areas, like in central Turkey, maybe in the south, the groundwater levels are dropping fast. In the north, which are relatively wet areas, northeast, there's like 200 centimeters of rain annually. So they do not have such a critical problem with regard to groundwater.
Thank you very much for this information. And Dr. Ale, you were mentioning about the African story in the fourth chapter was kind of very heartbreaking, the sub-Saharan Africa, and also the history about the Cape Town. So they were all amazing points. And the issue with how we're gonna handle the drought is a question. How are we going to do that? Like policy is an issue, infrastructure is an issue, conservation is an issue, and rain is also. And some also using like the prayer. Also, we do that too. People constantly are praying for the rain. Yes, so these are very interesting approaches, and we learning from your book how policy is crucial and extremely important in reserving the waters and groundwater sources as well, and infrastructure and conservation is a must. We learned a lot from you. All of your chapters, the groundwater contamination was a heartbreaking one since I worked on toxicity. So, and all these stuff. And thank you for writing this book. We're done with the time, so I don't want to keep you more.
Yeah, I've got to go too. I enjoyed it talking to you and hearing about Turkey actually myself.
Thank you so much for honoring our meeting. All of our professors and Dr. Ali, and please give our regards to Mrs. Ali. So thanks again, and to all of our attendees and for their willingness to learn about groundwater and protecting the water. So now after this today, we're not going to just say like surface water, we will think about groundwater. So
okay.
Hope to
Thank
see you
you.
in the next book club. So have a wonderful day and good night.
Okay, you too. Bye-bye. Thank you, everybody.